right? So we put a single quote in the front. We put a valid parameter in there, 2, and a single quote, our union clause, our query, and then we do the where 1 equals 1, right? Now we pass the string in. Now here, we're doing the where 1 equals 1. In the last example, we did where 1 equals 1, so we get returned 1 record, and then we can increment up from there. This time we're doing it for a slightly different reason. This time we're doing it because we need the string at the tail of our injection, because we're going to we're going to throw a single quote at the beginning of that string, but not the end. The reason we do that is because we know there's going to be a single quote hard-coded into the code. So when this gets injected and sent into the clause, right, the programmer opens up a single quote, says error code equals something. I'm sorry. Forget this this blue. That's a mistake. The program code equals and inserts a single quote, right? Then we have the value 2 in our own single quote. So we closed out the programmer's opening quote. Then we have the injection, but we still have the programmer's closing quote to deal with. So we put in our own string and we leave our closing quote off, right? We get stuck in the middle, the programmer's closing quote gets stuck on the end of our string and closes out our string, and we nullify the programmer's closing quote at the same time. This sort of escaping, right? This concept of doing things like putting things in to break out of tags and queries and closing things out is very, very common in injection attacks, whether they're script injections, HTML injections, SQL command, file traversals. It's kind of like padding in shellcode, I think. Very common techniques regardless, and you have to be familiar with techniques like this, even if you're not dealing with strings. Now, I talked about how we're doing the where clause here for a different reason. We're not doing the where 1 equals 1 to create a true condition and just pull up the first record in the table. We're doing the where 1 equals 1 to give it strings, right? So that we can intentionally leave off our trailing quote and have that closed by the programmer's code. So you don't have to use where 1 equals 1 here. Again, it can be anything. It can be any string in any combination that makes sense as a clause that gives you the ability to leave off that trailing quote and have it closed by the developer. A lot of times you get trapped in the middle of a query. Like you go into a column name and then there's a where clause behind it that has no dynamic input that you can't deal with, right? So error messages equals error code, and then browser input, and messages like error or some other undefinable term. You can break out using commas, dashes as a line comment. You can break out sometimes using semicolons, which is an end of line character. But this is a very common way of breaking out of those queries. You do your normal injection, and you throw a comment at the end, and that nullifies everything that comes after it. It nullifies the programmer's query, the rest of the programmer's query. If you don't do that, and you throw in the 2 union select card number from bank cards, right, you're going to get a pretty obvious error message that's going to tell you that you're doing something wrong. The quickest, easiest way you can get to an effective injection when you start getting error messages back saying something's wrong is throwing in commas, throwing in semicolons, right? Do your injection, throw in a semicolon at the end if you want, and throw some comment characters at the end, and start nullifying stuff off and reducing things to the basics. Conversion attacks are pretty neat. This is something I've been doing a little more work on. They're relatively new to a lot of people. They're new to me. I've been studying them myself. I don't want to say it's no day. I can't say it's no day because I seriously doubt I'm the first person to figure this stuff out. But SQL is a very strongly typed language, just as strongly typed as .NET or anything else. If that database column is typed as an integer, it wants an integer in there. If it's typed as a float, right, it wants a float. You can do explicit conversions, and the database will automatically do lots of implicit conversions for you, which are very interesting. Explicit conversions can be done in 2 different places. You can do it in the SQL code so that your PHP or ASP passes whatever, and the SQL converts it to the proper data type. Or you can do it in the ASP code, which honestly is the better way to do it. There's a lot of different reasons to do it in the ASP versus in the SQL. First of all, you don't want to be passing bad data types off to your database server, even if it is going to fix that for you, right? You want everything to be very controlled and rigid, but it also gives you the ability to trap errors. It's a very good validation technique. If this application takes expects and integers, but it takes any form of input, a really good way to do validation when it comes to database queries is reduce everything into integers as much as you can. Use lookup tables and hash tables and the sort, as opposed to taking strings, and then cast things to an integer. Right? If your application expects an integer, cast it to an integer. If it fails the casting, it's obviously not valid input. But either way, you have to have data in the correct format. Now, these conversion tricks are definitely an MS SQL Server thing. I don't think these will work on any other servers. The old convert attack has been documented for a while. This is the only conversion trick most people know about, and I learned about the other conversion tricks. I was forced to learn the other conversion tricks on jobs where I couldn't get convert to work for one reason or another. But convert is an explicit convert, right? The method signature is convert, data type, comma, value, or expression. This is the interesting part, or expression. So I can give it a string that actually has a number as the string, a string of 1, and tell it to convert to an integer, and it will convert that string 1 to the int 1. I can convert the nvarchar. Here's an integer, right? 1, 2, 3, 4, 5, and I can tell it turn this back into a string instead, and it will do that, right? It's the same value, but it's a different data type now. Now, if you tell it to convert from one format to another that's incompatible, it will give you an error. So if I give it a string and I tell it to convert this string to an integer, it fails. Now the original string here, this is what I did here, but the string's value actually is an integer, so this isn't the right allegory, but it kind of strips off the single quotes, so to speak. Let me make this an integer. Oh, it's the number 1. Yes, I can make this an integer. If you try to do that with something that is not a number, it fails. But this is where it gets interesting, because when it fails, it tells you what it failed to convert. It said, hey, I can't convert this word fish into a number. It's a word, not a number, right? And that's where it gets good, because the convert command will work with a value like this, or an expression like this. You can give it a query and tell it to convert the results of that query into an integer. And it obviously can't do that. When you do select top 1 name from sysobjects, the result is going to be something like credit cards or bank logins, right? And it can't turn that into an integer, so it fails, and it tells you what it couldn't convert. It says, I failed to convert the value bank logins to a number, right? And it's great information linkage. Now, it only works on one field at a time, so you have things with the top 1 name and then use the incrementing tricks to roll through the table. But it works beautifully. And the great thing about converts is they're small, and they'll work in areas that other things don't work. I can't give you like real specific examples of characters and places and the sort, but generally when I'm having trouble with injections and things just aren't making sense, I can fall back to a convert and it'll just work. It's a great standby. I did a job once where a convert wouldn't work. They were stripping out commas, not quotes, not parentheses, not union or select or where, but commas, and only commas. And it was frustrating as could be, because I tried to do a union attack, and the union attack failed. When you do a union attack, you have to select the same amount of fields that the programmer did. It's just like an algebraic equation. Both sides of that equation have to balance out. And if you how many fields they selected, you have to start counting. You have to say, okay, union select name from sysobjects. And you can actually select the same field twice and say select name, 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 and keep counting up. Or you can select strings, right? Which is actually kind of neat, because if you do get it all to come back, you can see exactly where the records are placed in the HTML. But either way, you have to count up until your column number counts the programmer's column number, and you can only do that with commas. So I tried counting up in my union attack, and they were stripping these out so that my query made no sense at all, and it stumped me. It was frustrating because it was a really crappy website. It was really poorly done. It was blatantly bad, and I was getting stumped because of commas. Now, if someone stripped out quotes and that gave me trouble, that'd be one thing. If they were stripping out like certain keywords, that'd be but I know they weren't stripping commas as a security technique. It was some functional problem they had where someone said, oh, we can't let people put commas in there. But sure enough, it was giving me a hell of a time. So I switched back, right? I fell back to the convert attack. But sure enough, look at the method signature of convert, right? So I'd say convert, and everything would come out as, and the error message would show me this. This is a good way to test validators, because the ODBC error message would actually say, makes sense, and you get to see what actually got sent to the database after validators. So my converts were coming out like this, right? So that didn't work. So I had to think fast, and this was on site with them watching me after I'd talked a lot of smack, which I do less of. If you saw, like at ShmooCon, a lot of smack at ShmooCon. I figured something out. I'll get to it after this slide because I forgot this slide was here. The neat thing about converts too is you can use it to tell what the data type of a column is. You can say select top one error code from error messages. I go to sysobjects. I see that there's a table I'm interested in. I go to syscolumns. I see there's multiple columns. Maybe I want to know what the error code column is. I need to figure out what the data type is. So I try and select top one error code, and it comes back and then it says I can't convert into text, right? So now I know that the error code field is defined as an integer. Nice side effect. Lots of interesting behaviors in these conversion tricks that give a lot of information out. Gosh, I hope I have my cast slide in here. Getting numeric values is a little trickier, and this is an area I'm still working on. Let's see, here I tried to convert the error code, right, to an integer, which I just learned the error code is an integer. And so now I say bring back that error code value and convert it to an integer, right? And so what does the database do? It converts it to an integer. It works. So there's no error message. I get the record set back, which is a field name. And that's a problem because the whole reason for using the convert is to have it convert things that doesn't work and breaks, and the injection works. So there are some tricks you can do with that though. Depending on the size of the number in the field, you can try to convert it to a smaller type of number. Integers can go, as you can see, can go pretty darn high. But you have small ints, which are actually not all that small either. And then you have tiny ints, which can go as high as 255. So if you're dealing with large numbers, card numbers, social security numbers, you can try and convert those down to a tiny int. And sure enough, when you overflow that field, it comes back and says, I can't convert this to a tiny int because you're trying to give me a number that doesn't fit, right? Too big for my bucket. So that works. If it doesn't overflow and the conversion actually works and you get the proper page back, that tells you the value is less than 255 because it fit inside the tiny int. I'm not sure of a way around this. I actually tried doing double conversions. It doesn't work. I tried saying, select this error code and convert it to an nvar car and then convert that to an int. And it didn't fall for that. I tried saying, select top one error code and and add 255. That didn't work either. So I'm still working on a way around this. The cast function. When convert could not work for me, I did some digging. SQL Books Online, right? You always have those on your hard drive. They're